My name is Sam Armstrong. I am the technical lead at the Center for Applied AI, and I'm going to be talking about SmartState today, which helps researchers automate their research studies. So the motivation behind creating SmartState stemmed from a collaboration that we had with the Department of Biology at the University of Kentucky, where these researchers were studying if implementing a fasting protocol within a set of postmenopausal women improved their metabolic health. Initially, they were collecting data via text message where the participants would text in when they started and stopped calories for the day, and they would manually take these measurements from their phone and copy it to a spreadsheet that they had, and then do some calculations and then send the participants feedback based on their fasting times. So we wanted to automate this process and kind of create a system around that where it can automatically interact with these participants and do these calculations for them. So unlike traditional systems, SmartState uses state machines, which are a group of states and a set of transitions between these states where a participant can be in at any given time. And if they send in a text message, then that moves them between states, or if they miss a check-in, that also moves them between states. And this way we can have kind of a set structure and a verifiable audit log of where the participant was at any given time. So at the core of SmartState, it has the state machine, which manages the participants within the study automatically. Then we have the messaging system, which we implemented with Twilio, which is a programmatic-based text messaging, emailing system. And then to wrap around all of that, we have a web-based interface where the study admin can log into this site and see these text messages being sent, send out text messages, and also see what the participant is doing, see what state they're in, see what path they're taking through the state machine, and also check in on them. And then with that, we also have a way to extract intent from text messages for these unstructured messages. So by doing that, we have this LLM layer where we can send the text message with some context to the LLM and say, hey, we need to extract these 3 things from this message. Are these 3 things in this message? And if so, what are they? Give it to us in a structured format. And with that response with a structured format, we can then save it in the database and do some calculations on it and kind of work with it from there. So SmartState integrates with LLM Factory, which uses Meta's Llama 3.1 to understand the natural language inputs from participants. This allows for automated structured data collection for these participants and reduces errors and miscommunications. So we started out with the intermittent fasting study and then built on that to allow it to be used by different domains. So we have a collaboration with the Cardiothoracic Surgery Center along with the Department of Athletics. If SmartState receives a text message from a participant that it doesn't understand, the LLM should send a message back to them saying, we're missing this part of the information, can you send it to us? For example, what time did you take your beta blocker? That question would have kind of 2 parts in it, and we would want, did they take their beta blocker and what time they took their beta blocker? So if the participant responded with yes, then that wouldn't be enough information to say that's an adequate response for that question. So the LLM would then send back a message saying, hey, we know you took your beta blocker, what time did you take it? And then the system would take that, store it as a structured format in the database for later use. And if after 3 attempts to get the extracted information out fail, then the system will flag it and send it to a study administrator to interact with the participant manually. So SmartState operates in a HIPAA and NIST compliant facility. The database is also encrypted at rest, and also we use SSL TLS encryption. Access is also restricted to the website for authorized research study administrations only. SmartState is immediately scalable by using tenantization, where we can have multiple studies encased in a single application. This allows a single research group to have multiple studies that then translate into separate but combined research outcomes. Currently, we're adding image recognition for the plant-based prevention of diabetes study, With this, we can determine how much of a meal has been eaten. So when participants send in a starting meal and an ending meal, we can determine from the ending meal how much of the meal that the participant's eaten. And with that, we can draw some reliable conclusions. Also, we're looking into using different LLM models. Right now, we're using Llama 3.1. We also want to add DeepSeek R1 to see if that draws different conclusions with extracting intent and see if it works better in any capacity. If you're interested in learning more about SmartState, take a look at our website. And if you want to collaborate with us, we also have an intake form on the website that you can take a look at. But this has been SmartState. Thank you for your attention. Have a good day.